Hello everyone. Today we'll be covering October-November 12, paper 42 of CIE A-level chemistry. Question 1b. The relatively trickier part of this question was part 6, B part 6. However, you required the values from everything else before it, so we'll be covering the entire part 1b. And the reason why it was tricky was because a question like this, or a question similar to this, has never been worded like this before. If you haven't given a go at the question, I suggest you do yourself by pausing the video and then later unpause to check your answer, or if you weren't able to do it, see how it is done. Okay, I hope you have attempted the question. If you've gotten the answer, please feel free to skip towards the end to check your answer. If you haven't, let's proceed through the whole question. Anyway, so the question, FeCl3 is used to dissolve unwanted copper from printed circuit boards, known as PCBs, by the following reaction. So you realize that this is sort of a redox where the oxidation state of iron changes from +3 to +2. So this you have to keep in mind, okay? And then the solution, in which Fe3 plus was originally equal to, the concentration of Fe3 plus was originally equal to 1.5 mole per dm cube. This is important, right? And was reused several times to dissolve the copper from PCB. And then it was titrated as follows. So first they ask you about this. So 2.5 centimeter cube of a partially used up solution. So this, the FeCl3 solution, it was used up. So because it was used up, what it means is that the iron was reduced to FeCl2 or Fe2 plus. So this is the volume, okay? Was acidified and titrated with 0.02 moles of KMnO4 or potassium manganate, and this is oxidized by NaFeCl2 and turned this oxidized NaFeCl2 into FeCl3. So it oxidized whatever was here back to its original state. And it was found that 15 centimeter cube of KMnO4 was required to reach the endpoint. So this is the volume required, okay? So you have to construct an ionic equation between Fe2 plus and MnO4 minus. It's a redox equation, and despite it not being stated here that you must refer to the data booklet, you have to, and you have to construct a redox equation respectively. So the redox equation that I've constructed is MnO4 minus plus 8H plus 5Fe2 plus, which turns into Mn2 plus 4H2O plus 5Fe3 plus. Then the next part of the question asks you to state the ratio of Fe2 plus to MnO4 minus. So MnO4 minus is 1, so it's 1, and Fe2 plus is 5, so it's 5:1. Next question is calculating the numbers of moles of MnO4 minus used in the titration, right? So the number of moles would be N MnO4 minus is equal to Cv. So its concentration is 0.02 into its volume that was required, this one. So it's 15 in dm cube, so divide by 1000, and your answer will be, so it'll be 3.0 into 10 to the power minus 4 moles. And then you use this part here, okay? So calculate the number of moles in 2.5 centimeter cube of the partially used up solution. So you just use the molar ratio, 5:1, 3.0 into 10 to the power minus 4. Sorry. In 10 to the power minus 4 is to x. So x would be, so it's cross multiply. So 5 into 10 to the power, 3 into 10 to the power minus 4, which is 1.5 into 10 to the power minus 3 moles. And calculate the concentration of partially used up solution. So the concentration would be, you'd get it by N is equal to Cv. So the concentration would be N by V. The moles is what you calculated in the previous question divided by the volume, which is 2.5 centimeter cube. Is given 2.5 divided by 1000 to convert it into dm cube, right? So answer divided by 2.5 divided by 1000, and you'd get 0.60 moles per dm cube. Now this part is the trickier part. So it asks you to calculate the mass of copper that could still be dissolved by 100 centimeter cube, this volume, of the partially used up solution. Now, what it means to say is that by the partially used up solution. So in the previous question, like in the previous scenario, what you find out is that 0.6 moles per dm cube of iron 2 plus, was oxidized by MnO4 minus, right? So from the original solution that's used to dissolve copper from PCB, which is 1.5 mole per dm cube, 0.6 moles per dm cube of that solution was diluted. That means like the iron 3 plus was turned into 2 plus. Okay, so the new concentration of Fe3 plus would be, I'm pretty sure most of you would have guessed it, 1.5 minus 0.6. So this is the concentration, the new concentration. This is the new concentration, like whatever is left in the partially used up solution, right? And then you use that to calculate the moles of iron 3 plus in the solution that can still dissolve copper. So Cv is equal to 0.9 into the volume, so in dm cube, which will give you 0.09 moles of Fe3 plus. You go back to the equation, you see that Fe3 plus and copper are in 2:1 ratio. So the moles of copper would be the moles of iron divided by 2. The answer is 0.045 moles. And then you use the last equation, N is equal to M by Mr. Therefore, the mass of copper is equal to its moles times its AR, actually, but there's a formula. So its mass would be 0.045 into 63.5. And that is 0.09 divided by 2. And that answer turns out to be 2.86 grams, rounded to 3 significant figures. I hope you understood. If you do have any doubts, please leave them in the comment section below.